Well, here's a new little mini project. Since I've been driving the car a little bit, I've noticed, I don't know, you might call it a bit of vagueness around the centre of the steering when straight ahead. Could be my imagination, maybe not. Now the front suspension on this is basically MGC, so not MGB, MGC, although when I say that it's largely Gilbin. What do I mean? So the stub axle and the kingpins are MGC, but the springs and wishbones are Gilbin. Now I don't know what the caster angle is, but I would like to know. It's pretty common for cars of that era without power steering to have a pretty small caster angle, and later cars with power steering tend to have a larger caster angle, and it's all to do with sensitivity in a straight line and so on. Anyway, that's the background. I have had this same issue some years ago with the Dutton, which I'll just swivel around and remind you what that looks like. There it is. Now the Dutton had Dutton's own wishbones and Ford Escort uprights, and I did have a similar issue. Anyway, back to this. So how do I measure the caster angle? Now, caster angle is, and that's caster with an ER, by the way. It is an imaginary line drawn between, well, vertical, and an imaginary line drawn between, when viewed from the side, the top and the bottom. Well, I was going to say ball joints. Of course, it's a kingpin, but I think it amounts to the same thing in the end. The top and bottom swivels, but when viewed from the side. So that is caster angle. And the way to measure it, because you can't get in there directly, well, maybe you kind of could if it's a kingpin, but actually no, you can't, because it's not the angle between two real things. You have to look at it from the side, so it's kind of tricky, let's put it that way. However, I know how to measure it, and basically you measure caster angle indirectly by measuring the difference between the camber angle when it's set, when the steering is one way, and when it's set the other way. And you can measure, due to the difference between left and right, how much the camber changes is itself a measure of caster. That's the theory, and it did work out, as I mentioned before. But the first problem I have in doing any of that is I need to measure, as I said initially, camber. And my camber gauge basically relies on me attaching this spirit level using a magnet. And I'll show you the thing. So here is my camber gauge, which I'm going to use to measure caster, and it's an adjustable spirit level. You can see a little bubble in there, and it's fixed on to the wheel with this magnet, but the magnet requires a magnetic thing to fix onto, and my alloy wheel is not magnetic. So previously, on other times I've done this, I've been able to avoid the problem of having alloy wheels by kind of poking the foot of this thing through until it goes onto the brake disc, which is the same orientation obviously as the wheel itself. But in this case, the holes in this Gilbin wheel aren't big enough, can't get the foot through, and I can't do it without the wheel attached. I can't do it, jack it up and take the wheel off and put it directly onto the brake disc, because, as I've mentioned, I need to measure the steering angle, so I need the wheel on to do that. So that's my first problem, and I thought fairly long about that, but then realised that I can actually do that using a gadget. And this is going to be my gadget. Because this piece of angle is dead straight, there's also, coincidentally, just the right size to go between the top and the bottom of the wheel rim, and it's got a nice big flat face on it. It means I can measure the angle of the camber of the wheel. However, what I can't do, because it needs to be on there kind of for a long time and swivel backwards and forwards, I'll need some way of fixing it on there semi-permanently. So I'm going to have to make a thing to hold this piece of angle iron onto the wheel so that I can manipulate it. It's a good note, wasn't it? So the first thing I'm going to do is I'm going to drill a hole in this, and we'll get a bit of threaded stuff and hook it over the inside of the wheel. So here is my gadget. I've just made this sort of clamping arrangement. This large washer here just clamps over the back of the wheel, and it basically hangs the whole thing onto the wheel rim, as I shall now attach. So here it is. So the threaded rod, which is way too long, just clamps the big washer in there, hooked on the back of the wheel. And the important thing is the fact that it touches the wheel rim there and there without touching the rubber. Perfect length, this piece of angle. So that is obviously parallel to the face of the wheel, and it's magnetic. So with my newly magnetic wheel extension, I can put that on there. This is my camber gauge, and I will report that it's got about 1.7 negative. Now this does a little bit depend on flatness of the ground, but it's pretty flat in this dimension. This dimension is a different matter. It does definitely go downhill, but I think to an order of significance, that is yeah, just over 1.5 negative, which is pretty good actually. I will do the other side eventually, but obviously I shall do more on this side before transferring all this lot over. Now, the other thing I've got, which I did use before, is some turntables, calibrated, which I'll get out of storage. So here are my turntables, and they're basically slidey spinny things with a scale, and obviously both of them the same. And the idea of these is you put them under the wheels, and that gives you a calibrated angle, and it's best to put the pins in initially so that you can get your wheels straight ahead, at least to begin with. These have been in storage for a long time. They're a bit rusty. They're also blinking heavy. They appear to be made of solid steel. So anyway, they do the job. So let's jack the car up and put these under the front wheels. Right, we've got one each side. The other one's slightly out of view, but now I need to pull the pins out, which restrict the movement of the turntable until you're ready. And to do that, I'm probably going to have to pull out. I'll jack it up a little bit more. Oh no. Okay, I can get that one out. Same on the other side. All right then. So I'll take you over there. So what we're going to do ignore this great big thread here, by the way. It's completely irrelevant. I probably could cut it off. I'm sure I could cut it off, but it just so happens that I haven't. So hopefully oh, that's interesting actually. So the camber, which was a minute ago was 1.5, appears now to be more like half. Let's check my clamped bracket thing. It's still clamped perfectly well. So why has it changed? Why would it have changed? The car's been jacked up. It may be indicating movement in the suspension bushes. That's the only thing I can think of. But anyway, one thing at a time. So I'm going to, that is very close to actually zero. I'm going to check my calibration. Now it just so happens the frame of the garage door, which is bolted to the garage, obviously is magnetic, and I can just put this on here and I'm pretty certain it's vertical. Okay, I've zeroed it, perhaps more accurately, I don't know. And it's now reading ½ degree negative on this side. So I'm going to change the steering angle now to be 20 degrees one way and then 20 degrees the other way, and check the difference. Right, so we're going to turn the steering until it reaches 20 degrees. Okay, 20 degrees. There's a little tiny bit of rotation on the wheel, and it's now reading 1.25 positive camber on that side. So it's 1.2 positive when it's steered to the right, and I'll now do the steering to the left version. Right, 20 degrees that way, and we've now got basically 1.5 degrees negative. So I'm going to have to go and look up now what that means. Do you add the numbers together? 1.25 plus 1.5. I've got a feeling that might be it actually. Let's assume I'm correct for a minute. 1.5 plus 1, that's 2.5 plus that's 2.75. 2.75. I think that's right. And to be perfectly sure, of course, I need to do the other side as well. But it's looking like something like 2.5. Is that right? 1.5, no, 2.75, sorry. Right, so that's definite then. That is a caster angle of 2.75 degrees. Alright, okay, in round numbers we could say 1.5 negative to 1.5 positive, which is 3. So, it might be a bit less than 3, but it's about 3, which is fairly typical for a car of this era. I'm going to go and measure the other side now. I'll hook on my bracketry again. It's possibly a bit easier to see it in this way round. The whole point of this threaded thing is purely to clamp it to the face of the wheel. That's all it does. There's no calibration involved here. In fact, that might be good enough, but I'm going to tighten up a little bit anyway. That's fixed to the front of the wheel. Now it just so happens, actually I'm going to do what I did before. I'm going to take it to 0. No, I'm not. I'm going to leave it exactly where it is. Right, okay, so this is all ready, and I'm slightly surprised that it's 20 degrees to the right already. But here we have a reading of just over 2 degrees negative. So I turn the steering 20 degrees the other side. Near enough. So making sure that the thing is level. So this is always get some rotation. When you do the turning. Alright, so on this side looks like we've got just under 1.5 positive. So there we have it. Again, it's roughly 3 degrees of I'm never sure whether it's negative or positive caster, but anyway, we got just about 3 degrees of caster, and that's really what I wanted to know.